think you got it.
All right, you're up. If you would please introduce yourself and you're good to go.
I shall. First, I wanted to give compliments to Tammy, Lou, Mike, and the whole Requirements Working Group. This is awesome today. This is fun doing these kind of pre-meetings, and the product family they're putting together, we're putting together. I'm a real fan. The manual, I've already been using it on the NASA Gateway program to kind of validate and provide some guidance for our validation V&V program, our DNV program. So I really love the stuff you're doing. So just wanted to pass that on. So first, I'm Tony Williams. I'm a chief engineer with Jacobs in Houston, where we are supporting Johnson Space Center in the development of flight systems, Orion, Gateway, Artemis, and so on. I am an ESEP, and I have 4 more days in the role as the director for the Americas sector, where I've been enjoying for the last 4 years, working with the chapter side of INCOSE. So with that, a little bit on this work. This work has actually been presented in partial and prior forms, and this is the first time I've actually been able to tell the story end to end. So you may have seen a little bit of this at some point. If so, apologies, but this is kind of the what really happened version. So with that as a starting point, I assume I'm still presenting. I'm going to walk through a little bit. This is on the Orion Ascent Abort 2 program. The Orion Ascent Abort 2, as I'll tell you in a minute, was a test of the abort system for the Orion capsule. And in this case, the team I was on, we built the crew module, the part that emulated the Orion capsule in this. It's kind of fun. I've got some videos as well. So it's not only a story about system engineering, it's kind of some cool stuff with fire coming out the end. And who doesn't like that? So I'm going to tell you about what we did and the real heart of the story. And it goes back actually to a conversation I had with Lou 4 or 5 years ago about the concepts he was pulling together in terms of data integration and integrated data as the center of system engineering. You're going to see a lot of that. What I want to really do, though, is based on that as a going in point, basically do a little show and tell on how we actually use SharePoint, which a lot of people look down on, as a reasonable and appropriate system for requirements management, for verification, planning, and execution, and closeout. So with that, and I also don't have any obligation to use the whole hour, so I know we're holding people from dinner and so forth. So to kind of set the context, this is the Orion flight test program, and Artemis 1 is actually coming up within the next 60 to 90 days, if all goes well with their wet dress rehearsal that's coming up. What we were is the Ascend Abort 2 test, which is the third one, a little short one that looks like an electric toothbrush. We actually tested in the dynamic environment the ability of the abort system to work. There was a pad abort before that. That's the only test they were doing for that verification. And it was a validation specifically. It was collecting data that would then be used in a lot of different ways, but it was not explicitly a verification of a specific requirement or set of requirements. So a little bit more about the mission. Obviously, we wanted to demonstrate that the abort hardware and software would work together. The mission was really about data. We were collecting multiple hundreds, thousands of data points of data and downlinking them, as well as we built some data recorders that would be spit out to allow us to recover them after the flight and make sure that we got all the data. The mission, and I'm going to play the video for you, lasted less than 2.5 minutes. We were trying to hit a fairly high condition of Mach dynamic pressure and angle of attack. We were expecting to pop the abort at around 29,000 feet. And one interesting thing about this particular test is we had no parachutes. We've already tested the parachutes pretty thoroughly for Orion. There was no real reason to spend the money. So you have this rather horrific sight of the capsule falling into the ocean without chutes. So I'm not going to show you that part. I have to brag a little. Jacobs, my company, was all over this mission. We were involved from end to end, from running the facilities that built the crew module in Virginia, from the vibration and acoustic testing in Ohio, from building the developmental flight instrumentation out at Dryden, now Armstrong in California. Here at Houston, Johnson Space Center, we integrated the capsule and we built some of the subsystems. And in Florida, we provided the launch operations. So enough bragging about Jacobs. Let me show you what we're talking about. And this should work. If not, I've queued up another screen where it will work. There we go.
Five, 4, 3, 2, 1, ignition. And this is the LC Minotaur launch vehicle is carrying the AA2 launch aboard system for a full stress test.
That would be the view I had from the canal boat. So at about 29,000 feet, we initiate the abort. It was pre-programmed. You'll be seeing that any second.
Mach 1.
Right after we hit Mach 1.
Mach 1.1.
Okay, in about 10 seconds, we will see the abort.
And there you go.
Abort initiation.
Pyros 1 and 2 discharge both sides.
So the abort motor pops the capsule away from the booster, coasts for a while, it does a rotation, and then the rocket, the abort rocket jettisons from the capsule, and the capsule begins to free fall. There is the rotation. And the jettison any second. Boom, there you go.
Pyros 3 and 4
And there's your
discharge both
capsule
sides.
without parachutes.
Squib power enabled.
So there goes the LAS, tumbling a bit, Orion coming down.
Started data
Everything looking
rebroadcast.
good so far.
Recall there are no parachutes on this test today, so once the data recorders have been deployed and the vehicle is no longer transmitting data, TC will call test complete.
And that's
We're
basically
looking now
what we
at the
wanted to show you.
Data is being written. We're about to get ejected.
All right, let's go back to my presentation. Sorry for the if I can get back to my presentation, I'll continue talking. There we go. Okay. So that was the fun and games part, the actual mission. So let's talk about the setup for how we managed to proceed on somewhat of an experimental path. So we very consciously on the SE&I team for what we call CSR, the crew module and separation ring, which is basically the crew module emulation that we flew for the test. We had to tailor, and every good system engineering team focuses a lot on upfront tailoring. I think it's one of the things that is so critical to us as professionals is to make sure we don't just take the book and start applying it, but really look eyes open at how you need to change and modify what you're doing for what you're doing as far as the mission. So in this case, we were going to fly an uncrewed flight test. So that already would start saying maybe my level of rigor doesn't need to be the same as it would be, say, for Artemis or Orion. But on the other hand, this is a key test on the Orion program. We really need this to work. So there's some element that says we can have a little less rigor, but other elements say we need it. On the other hand, we were part of advanced spaceflight development, and we were funded in part to prototype and experiment with new ways of doing business. And as part of that, we were encouraged to innovate, and we were told that the traditional business processes at JSC wouldn't apply if we can show that we were going to meet the requirement in another way. So that gave us a large license to innovate and try new things. So we picked a risk posture, and what this chart's trying to show you is if you look on the right, these are human space flight, human safety critical activities, shuttle, ISS, Orion, lots of money, lots of reliability. And then you have on the very, very other end of the scale, tech dev, R&D, where failure is not only possible, but sometimes encouraged, so you learn. And we decided that we were somewhere in between those, and we had the opportunity to make some smart calls in terms of our project rigor, is what we called it. Rigor as in how many signatures did we need on specs and how many verifications did we need per test objective and so forth. So we picked a risk approach, which was consistent with a flight test. The hardware we did not treat as what they call class 1 in our world, which requires tracing the paper all the way from the vendor to the flight. We did what we would call more reasonable things. And we looked at ourselves from the perspective of a clean sheet approach where anyone who proposed a process or a way of doing business had to vote it onto the project as compared to tailoring it off. We started with expectation we were going to define the right things to do rather than remove the things that were wasteful. So this should look familiar to y'all. Lou probably remembers back when we were talking about this and how this really resonated with the AA2 team. We were all about the idea of sharing data and trying to minimize the amount of stovepipes, minimize the documentation approach. We wanted it to be a data-centric program. And so we relied on the white paper a bit. I relied on it and shared it with my team. And we tried to emulate this, and we got pretty well. We did it a bit, I would say. As a next thought, if you think in terms of project collaboration and things you might do in SharePoint, and most folks are familiar with SharePoint, kind of the first thing you do at the top is you put some folders in and you store some documents. And maybe you've got some web pages that give announcements out. If you go all the way to the other side, where we were aiming was for the technical team, whether that be the avionics team, the T&V team, the power subsystem, the analysis team, would actually jointly develop their products within the SharePoint environment, and usually not in documents, usually in the form of databases called lists or wikis. And that was where we could do the collaboration directly in that environment, rather than having someone go off and build something and then come back and deliver it. If you think about the typical way project archives start, they start off with a nice clean foldering system of some kind. This is maybe a little tongue-in-cheek as a laptop foldering system. But entropy happens, of course, and that organized, clean system, number of things happen. Folks may become less motivated to take care of certain pieces and they fall out of date. It becomes bent and pushed in different directions until it really is hard to find things. We use SharePoint to take advantage of a lot of the metadata and use that to link things together. And what you're seeing here, and I know it's an eye chart and we'll show some better examples later, is actually our critical design review portal. And this is a single web page where we included links to everything from the development or the presentations to our objectives and criteria for both entrance and success, to the evidence for that criteria, to our action items that were being submitted by the team, to our assessments and so on. And it was all being integrated through the use of these databases behind the scenes with linkages between them. And we'll show you how that works in a sec. We came up with a schema that met our needs. And unlike a lot of our projects, we integrated with PM data as well. We had a single risk system, and that risk could link to requirements or tests, or it could link to budgets or schedules. And what I'll walk you through in the pink now is our SE side of the schema. At the very top, we're showing the customer, our customer, the level 2 part of our project, which was the mission, had their requirements in a list, and it was in SharePoint conveniently enough. So we could develop, implement traceability, a requirements traceability framework by creating our requirements and linking up to them. And I'll show you kind of a little bit of our requirement development methodology. On the left, you see functions and interfaces. We would model and track those functions and interfaces, and then we could show how those were being implemented by requirements. Similarly, the architectures that resulted from our design were then allocated requirements based on that. Obviously, you have the TBX list. Down at the bottom, you're seeing safety hazards and controls. We had to show that we had mitigated our safety hazards. On the right side of the figure, you're seeing our traceability through into verification requirements. And what we call the test and verification activity. Classically, I think they call this a VA, a verification activity, or a VE. In our case, we were using it for non-verification as well, If we were planning a test, we would include it in our planning. That word you see there, TPS, that was an automated test procedure system that we developed as part of the project. And then you can see the other kinds of things we had to track, the discrepancies, the test configs. When the test was complete, we used that same TVA database to capture the rationale for verification closure, and the peer reviews were the feedback we got on that. On the right, you can see some of the PM stuff, and I can walk through all of this, but I think you're getting the idea. And these linkages were fairly simple linkages that did require the human who was doing the work to understand the relationships. It wasn't a dummy down system. But if you understood what you were working on, then you were able to use these built-in relationships to perform that traceability. So I'll give you some examples of what we did. Let's start off with requirements definition. We started off with focusing in on our ConOps, and this ConOps lived in a variety of graphics and maybe was carried around in the briefing, but we did use a few tools to develop those elements of the ConOps, whether those be design reference missions, activity diagrams, modes of operation. And we would take those diagrams, and the first thing we did was functional analysis on that. And the functional analysis, as you'd imagine, was the assessment of those elements of the system model of the stakeholder needs and trying to analyze them to identify those functions that are implied or explicitly defined and demanded by the ConOps. Similarly, we did the same for interfaces. What interfaces, both external and internal to AA2, were explicitly or implicitly defined, and then what sort of architecture are we talking about? How is that? And at that time, we had multiple options for architecture. We decomposed, and then we would allocate functions and interfaces, and then redo for the next architecture. And then finally, especially at NASA, but everywhere in the world, you're going to be handed a stack of other requirements you need to meet. Program constraints, environments perhaps you have to live in, parent requirements to meet. And those all four formed the basis for our technical requirements. Now, that doesn't sound very different from any project, but what we did that's a little different is we first did start off in other tool sets. And what I'm showing you here at the top is a mode diagram, and it was actually a process flow diagram, I believe, in Cradle. And Cradle does have a substantial modeling environment for those who aren't aware, who only are aware of it as a requirement monster. And then on the right in Magic Draw is a sequence diagram. And the modes showed kind of the different states that the vehicle was going to be in. And then the sequence diagram showed the actual activities and the communications between the different elements. So far, where we use those tools, but then we produce them mostly as pictures because we carried them over, sneaker.netted them, in fact, into the SharePoint environment where we brought them in as purely as a JPEG. But what we did do is we created a system functional list and a system mode list, and those became dynamic. Now, we did have to iterate a few times across that error gap, but once we had that set of functions and modes captured in our list, we were then able to dynamically link to that list and trace throughout the rest of our infrastructure, going from functions to requirements to verifications and so on. So I know it's an eye chart, but what you're seeing there is the function name and description, who it was allocated to, whether it was the crew module, the electronic ground support equipment, or the separation ring, and what modes was that allowed to operate in. That was our functional description. So from there, we're now able to say, okay, I can start working on creating some shalls that are necessary and sufficient. I like that term, Ron and Lou, for implementing those functions. And here you're seeing a little bit of how that might look. We have the allowable functions under this first mode, lab, L-1 lab init. We have the requirement statement that implements it, as well as the rationale and allocations. So we have all that in linked lists. From there, we start trying to define our verification for that requirement, just like normal business. But once again, we have this in another list, and we were able to link those two lists together and be able to look at all our verification requirements in one. And we're able to look at all our technical requirements in the other and then show them together in a verification requirements matrix. And in fact, yes, at the top there, and again, it's an eye chart, you're seeing in essence a snippet from a VRM, from a verification requirements matrix. You have the requirement shall, the VRID, and then the success criteria and method. So that allowed us to keep our stuff organized, not lose things, maintain traceability, and yet we're still doing it in a pretty lightweight environment. And you know, one thing I actually skipped over, we didn't just start off thinking that SharePoint was the key to the world. We traded off, and I was hard pushing for some of the more, quote, real system engineering environments. And the trade we really were focused in on was the question of power versus accessibility. And if you're working in a DNG or a Doors Classic or Cradle or any of these other serious tool sets, you know you can produce all sorts of great reports. You have a lot of powerful capability for traceability and analysis. But you also know that there's probably 5% of the project team who's ever going to touch it. And the rest of the folks, if they're in different subsystems or different disciplines, are never going to go there. And then on the other side of that same trade is tools like Microsoft and SharePoint. And while you may not have the out-of-the-box power, if your focus is on creating a highly collaborative team that are working on these things together, SharePoint suddenly looks pretty attractive, if that makes sense, because everybody on the team not only could, but did work in SharePoint and work together in these environments. So we declared that the subsystems, and we had 8 or 9 or 10 subsystems, were their own system engineers and would create their own set of level 4 requirements and verifications that would trace up in the same environment. So we didn't just have the system engineers and the team behind the curtain, if you will, working in this environment. And that was a big deal. Moving down the same thread we talked about before, we went from requirements to a verification requirement. What I'm showing you now is a snippet from a task performance sheet, which is an odd name. It's actually an electronic test procedure system, and you see a step there. And the cool thing that we were able to do in the environment was when we executed tests, we could actually real-time trace what requirement are we verifying. And here's not only a copy of the requirement, but the actual authoritative content for that requirement. And the children that went with it as well, you're seeing there in that snippet, the parent requirement for it. So you can play traceability games all throughout. And where that came into real benefit was when you had a question on what you were really trying to achieve with a requirement. And if you were able to quickly go to the parent and see what they said at the parent level, and then also see what function it mapped to, and perhaps also look at the children, then you get a pretty quick picture of what you were trying to achieve. Moving on. So this is another way of showing what I showed before. We went from the mode diagram that we created in Cradle, and then recreated, or not recreated, but then built the functions to support that in Magic Draw, created our list of functions, and then built from there the requirements that supported each function. And there was a question in the prior presentation about how do you know when you're sufficient or necessary? And what you're seeing here is for each function, and the top one is initialized, I can see the 1, 2, 3, 4, 5 specific requirements that we assessed as being necessary and sufficient to execute it. And while if you look at a pile of requirements, we had upwards of 700 or 800, it's hard for the human being to assess that from a goodness perspective. But if I just look at those 5 and say, do those 5 together achieve what I said I needed to do for initialize, then I've got a running chance at trying to make that happen. So let's see, I got a question. I'm going to pause and take that from Jaime. Did you have interoperability challenges to implement the links? From what I understand, it's a straightforward process when tools provide built-in integration, but that's not only the case. The answer is partially, Jaime. SharePoint is not a relational database, and we'll talk about that in a little bit. And what that meant is, while I could link a requirement to a verification, where if I looked at the requirement, I would then have a link to which verification it was implemented by, I could not immediately do the reverse. I could not go to a verification and click back to the requirement, because that's the bidirectional relationship I'm sorry, the relational database would provide that. We were not relational. So we did bring in a few, what we call the wizards, who are some SharePoint and Java developers who built some custom reports to enable that. So the answer is you're right. In some cases, it was really straightforward. In other cases, we had to make the system or make SharePoint do things it really didn't do before and build some custom applications. But our integration was from SharePoint to SharePoint. I didn't want to give the idea that we integrated between Magic Draw or Doors Next Gen or Cradle to SharePoint. Although as an aside, I'm actually doing that on the Gateway project we're in now, but that's a different story. Thanks for the question, Jaime. Okay, back to our story. So that's an example of the functional analysis. Interfaces were very much the same. We have an interface model. In this case, that's just plain old boring PowerPoint. But from that drawing, we're able to analyze and identify how many interfaces does this diagram show me. And then I built a dynamic list that then could be linked to requirements and to other interfaces and so on. And that's kind of the way the flow went. These are intentionally blurred, by the way, to ensure that I complied with export control worries. So that's why you can't actually read the words on them, but you get the idea, I hope. So that's the interfaces. So that was how we got the requirements developed. Now, since we were trying something a little, we thought, radical, we were not going to ever intend to produce a document called a spec. We were never intending to even spit out a PDF at first, but we did want to provide something that our customers and stakeholders would feel comfortable with that was a spec. So we were able, using SharePoint again, to start building a set of interlinked lists and wiki pages that together achieved the same impact as a spec, but still kept everything live and in our database. And when you looked at this spec, you were not looking at a PDF copy of what we wrote down a month ago. You were actually looking at the live authoritative data. So, you know, a table of contents, no big deal. Your typical title page information, your introductory sections we're able to provide. The reference list is a little cool. It's not just a list, it's dynamic links to those products. So if you clicked on any of those, you would actually go to the source product that you were looking at. We used another list that we called our architecture list to capture the system description and the description of the modules and the elements. And then we used the requirements list. We had multiple ways. We had the first view was show me my key requirements. My second view was show me my functional requirements. Third up was interface. And then fourth up was the design requirements, which of course you always have those imposed. And then from there, you were able to drill into any of these, even though you were in a spec, you had that live connectivity into the database, so as to be able to see kind of all the metadata associated with that requirement, as well as the official data. So that's how we created the specs. Moving on to verification planning. We needed to implement what I think of as a many-to-many relationship from requirements to VRs to VAs, meaning one requirement might have multiple VRs addressing it. One VR might be implemented by multiple, actually by one by one VA, but one VA might have multiple VRs in it. And one VR might support multiple requirements. So it could go in any direction there. We were able to build a lot of that just out of the box. And then, like I said, we had our wizards who were able to provide some additional tools for analyzing the data. In our world, the requirement, the VR was your success criteria. And I think this lines up well with the manual as well. The VAs were, I think of those as almost a project management element of system engineering. I'm taking the verification requirements I need to implement and meet, and I'm allocating them to teams, to labs, to people, to activities and scheduled times to make them happen. We put together with that VA list a one-page format that we used as our top-level test information sheet that then could get handed off and run with to turn into the actual test. Then we came back and actually used that same format to close, we would use that same verification activity page and turn it into a verification closure notice that allowed us to convince our stakeholders that we actually met the requirement. And we applied one thing that is built into SharePoint is a workflow system where you can route proposed closures to our peer review teams, and the peers would review them, either provide comments or concur, and that's how we close the verifications. This is going to be another one of those walkthroughs on the different pieces of that. So it's some more of these screenshots. So here you see our requirements list, and you see we've got a total of 263 in the crew module spec. You see the requirement rationale as well as the parents. From there, you can zoom in and see a little more detail, including any TBDs associated with this requirement. You can see the functional parent. So remember, we did our functional analysis and initialize was implemented by this particular requirement, which says provide status. Makes sense. This was not an interface requirement. Otherwise, the interface parent would be flipped in as well. And you can see a little bit of information on verification. But if you want to go to the next step, then you pop the link to the verification requirement. And this is where you see how we're going to verify that. We're going to show during startup testing, we're going to use our ground equipment, and we're going to show that the ground equipment is seeing status for each subsystem after startup. From there, you see the cm.ff.mm. That's the designator for a verification activity. That's where that verification was actually to be executed. That was a test. The test was called a full functional nominal mission. We had a laboratory where we could simulate the entire electronics of the crew module going through every phase of the abort. And we ran that thousands of times over the 2 years before the mission. And then we used that same test infrastructure, simulation infrastructure, to verify that it was doing what it was supposed to do. You see under the verification, not only the VRID, but what requirement it verifies or requirements. And the next level, we start talking about the verification activity. And this is that CM full functional nominal mission test. And we did this in Building 9 at JSC, if you're familiar with it. We had our lab and we had a mission control center that we were doing rehearsals on and verifications. And what you see here is a description of what we wanted to do, as well as, and this is the closure form, this is the VCN. And for the VCN, what you see I'm showing here at the top level is the requirement, the title, and then where in our procedure was that actually verified? And it was in procedure number 763, step 5010. So now I can flip over there, look at that and say, did in fact I do what I was supposed to do, and look at the test procedure and show that it actually happened. Now, when we'll show a little bit more of the test procedures in a moment. One area that I wanted to talk about, although not strictly speaking directly part of the SharePoint experience, is an area that I find as I work with system engineers is missed a lot. It's you've run the test. How do you now close that requirement, close that verification? And then, again, this is something I saw the manual does address, and it made me very happy. In some programs, you may have an established approach that's just put in place up front. But if you're dealing with a clean sheet of paper or a new project, it's up to you as the system engineer to figure out what your approach is for closure. And again, what I mean by closure is I've done the test. There's no outstanding issues or deficiencies. We closed all the paperwork. Now, how does that turn into closing the spec requirement? We elected to go with a zero-based starting point. And what we said is, first, tell me every possible way that we could do this approval approach. And what you see on the right side is we start off with none. We passed the test. As a system engineer, I'm just going to go close it. And then each letter down provides a bit more rigor. The first one is the lead for that hardware item. The hardware owner simply signs off and says, I'm good. The next one is he does the same thing, but he attaches his evidence as further review. The next one is he gets some peers to look at it and agree with him. The next one, and you can see that's the one we selected, is we not only have some peers reviewing it, but we get some peers from outside the project to look at us. And then you can see the other kind of ways you might do this. You get a next level review where if I'm level 3, Level 2 has to approve all my verifications. You might get, and some of these you can execute together. You could have an audit for completeness as a separate external activity. You could hire independent outside reviewers. You could do what they call at Johnson a FICA-PICA, a functional configuration audit, and or a physical configuration audit, where you have someone formally examine everything as an outside auditor. Given our level of rigor, as we talked about earlier, C1 is the one we picked for this process. And then we developed within SharePoint the tools to allow us to do that. I mentioned this not so much because of the SharePoint as because I think this zero-based approach is reasonable, especially for non-critical missions and non-critical programs. Not everything needs to be thrown in the book at of every level of verification. Sometimes less is better. So with that, let's push forward. I wanted to talk a little more about the different applications other than verification. This is our critical design review portal. And as you are probably aware, critical design review was in essence supposed to be our examination prior to being allowed to actually bang out hardware and actually put stuff together and buy stuff. What you see in this one page are first off a schedule, which is just a JPEG. The agendas are dynamic agendas with each one linking you to the presentations that were associated with those agendas. You'll see the entry and exit criteria. If you're familiar with the NASA world, NPR 7123.1, currently Rev C, has some guidance in their appendices, I believe it's Appendix G, that says if you're doing a CDR for a single project, here's what you should be bringing to the CDR, and here's what you need to show to get out of the CDR and pass it. So we used our database to not only, first off, of course, we took the original and we tailored it for our purposes, and then we took the tailored criteria and linked them to the product or products. These could be drawings, these could be analyses, these could be tests that we did previously that demonstrated that we were ready to move into the next phase. And so that was a way for reviewers to not just trust us, but they were able to trace along and say the criteria says X and link here, and oh yeah, there's your evidence that you did it. And that was really useful. The next is the product list, and that's kind of the inverse. The product list, when you go to CDR, are everything from subsystem specs, test plans, config management plans, test results, and so on. And that was our product list that was being reviewed, which was also linked back to the criteria. As you can imagine, if you're showing that your detailed design is in place, then showing that you have drawings and product specs is how you show it. We have lists of the open work, which every project has. On the top right, the way that reviews are done at NASA is we usually provide an environment for the review community to provide us comments. And these are usually technical gurus from across NASA, across Johnson in this case. And we provided them a way of, okay, I was reading someone's comment and I will come back to that in a second. We were providing the reviewers a way to directly pop in and add in their comments directly and link them. And then finally, one of the things that happens at the CDR, of course, is the board will assess you and say, are you really ready to go? And so we gave them a hand and provided our own assessment, and there's evidence underlying each one of those. So that just gives you one way this was used. We found it to be a fantastically useful way to organize a review. And for the smaller projects I've been working on since then, I've been implementing many versions of this to just organize the products. And so even if you're not using a SharePoint-based approach, using a tool set like this to organize your reviews is a handy way to go. I'll be right back to your question, John. Okay, I want to talk a little bit about the test procedure tool that we put together. This is, again, a SharePoint-based test procedure environment that allowed collaborative development of not only the test procedure to include identifying what equipment is needed for each step. Are there safety cautions or hazards associated with each step? Who needs to check off on each step? Is there a second checker offer or just the initiator? What needs to happen? Are there any requirements or verifications linked to that step? And one cool thing about this is we were able to implement this using tablets as well, where we could be building hardware have multiple reviewers and approvers walking around with tablets and be simultaneously checking off steps as they were executed without interfering with each other. Typically out here, we actually print out paper and have people sign it with a pen. It's kind of old school. So this gives you a little more zoom in on what that looks like. You can see the instructions: close SSR, solid state relay for LAS, that's launch abort system, DFI, development of flight instrumentation, side B. The ITOS page instruction tells you where to go to make that happen. Then you see in green that was completed. There's a place for adding notes. And then you have on the right where the OPR, in this case, the operator is able to click off and say, I did it. And you can see kind of what these look like. Down at the bottom of the next step, you can see a link to a verification requirement that step actually confirms. So the traceability was fairly impressive. Here's what happens if you clicked on that link I mentioned. It takes you to the verification requirement. And from there, of course, you can go back to the requirement, as I mentioned before, and you can even go back to the interface parent, S2B, on this one. There's the interface parent. It is the last OFI to CMDFI interface. So we thought that was a neat feature to have. We also had to keep track of what we learned in all of our runs, and so we created an integrated run matrix that kept track of the exact configuration we were in for that test, as well as what we learned, what the test results were, and whether there were any issues that popped up. In this case, there were 2 issues that popped up. So let's take a look at one of those issues, which we call the DR, or discrepancy. So this is what the discrepancy list says is the, in this case, it was the abort control motor computer goes into built-in test after an invalid PP command was set. And I don't even know what a PP command is anymore. It's been a couple of years. But you can see a fantastic level of traceability built in here. A little more in the ETS tool. This was more custom development. This was not out of the box capability. We're actually evaluating it right now for use in the labs at the Gateway program for testing at the system level. But it allowed us to not only do testing, but also to do fabrication, assembly, and hardware handling using these procedures. So I'm going to wrap it up at this point, and then we can have some discussions. I recognize that there's probably I tend to oversimplify a lot of processes, and I think that's what John hit on. And I'm looking forward to the conversation. So first off, for AA2, we succeeded. We had a successful test mission. We were able to use this environment to manage the things we were doing along the way, to organize, manage, capture our requirements, to manage the relationship between the requirements to their children, to their parents, to the TBDs, to VRs, to VAs. That worked out pretty well, honestly. Now, at the time, we did not have anyone that said, hey, don't forget to leave behind quality records so that we can look at your test reports and results years later. Because from our perspective, the test is over in 2 minutes. And assuming we passed, the details on how the crew module was performing at the time that the flight test was going on was not that important, because it's an emulation of the Orion flight model, crew module. It's not a real crew module. So we elected to not do a lot of quality records. In retrospect, that was something I would do better on the next time. We did learn SharePoint's pretty flexible and it scales really well. We were able to use a very open environment where we rarely put in access controls, but we could. We did lock down requirements after they were baseline, but that was about it. We also allowed our users to go off and work with the environment to build whatever they wanted to build. And they did a lot of building new lists, new functional testing approaches without anyone helping them, which was good. And then there was also cases where someone went off and did something that didn't make any sense and we didn't catch it till later. But that's a win-win, win if you lose if you, right? In 4 years, we did get to a state within AA2 where the data structures were starting to get cumbersome. Some of them were not being maintained. We would have needed more dedicated resources to be the data maintainers if we had gone on longer. It did require, however, discipline from our team members to not only remember where the right data was supposed to go and put it there, but to also keep it current. So that was true. And then finally, we were able to make SharePoint do the things that it didn't normally do by creating some custom apps using Java. And we didn't really have significant software development. The project team for the crew module separating was about 150 people, and we had 1.5 developers for a part of the time we were doing the work. So that's not a lot. And that was primarily in the areas of bidirectional traceability and procedure development. So with that, thank you for your kind attention. I've been wanting to tell folks about this. Please note that I'm not a SharePoint advocate, Microsoft salesman. I thought it was the right tool for the job at the time. But I also enjoy using the real fun tools for more serious high-level projects. With that, thank you.
I think we have a question from John Clark in the chat. I don't see any process in your charts for requirements validation. Would you please elaborate whether requirements validation, I'm assuming validating you have the right requirements, is a correct process, and how would that be done? I'm not sure if you meant system validation or requirement validation.
I'm trying to read that one. I don't see that one. Okay, answer your question. How do we do requirement validation? The first check was to go back to directly from the requirements into the ConOps type elements we have, the functional diagrams and the modes, and try to understand if we build the things that these requirements are saying we're building, are we going to build the thing we really want? And we actually produced some products at SRR that attempted to do explicitly that. They were more in form of PowerPoint, but we were able to use what we had built to show that the requirements we had were only there to implement the functions that we had shown in the ConOps that we needed. So that's a little bit of retracing our development approach for requirement creation, but that's what we did for SRR, for better or worse. So I know we could do better than that. This is a scary audience to brief to, I got to tell you.
I don't know why. I absolutely loved your talk. I think I heard this one before, and I was excited when you said you were going to bring it, because I think it's relatable. I think you give a great example. Not everyone works in the space industry. I appreciate that, but you've made it real with the mission video, and you made this very relatable in terms of a project.
Well, thank you. And I think a lot of us work on projects where we don't always get to choose our tool sets. And this was partially just to say, in the case where we really didn't get to show our tool sets, we still made this work out.
Well, I was a little jealous you got to choose your rigor. Actually, I thought that was really cool. I don't know if you see the chat. Henrik just wrote one more idea. I don't think it's a question. I think it's a comment. Yeah, you see that?
So John, I would definitely, I've been teaching requirement. I'm going back to the last question. In my requirement classes that I teach, I emphasize the need for requirements validation quite heavily. So I'm a believer there. Okay, Henrik, in the handbook, stakeholder needs, yes, is the first identifies functions, also matures life artifacts.
That was maybe not a question. It was a response to a conversation in the chat. So sorry about that. But
oh, no worries, no worries at all.
It was related.
I was just trying to understand it before I tried to talk to it. But
yeah, it was a discussion about when functions are actually first identified. I mean, maybe some would say, yeah, well, you do that in the architecture model. No, you do that when you work with requirements. No, actually, I think it's really up in the stakeholder needs and requirements process. That's when you actually start to identify those things.
Yeah, I think it drops with the level of detail that you're working on. I call it the cake model for model-based system engineering, where you first work at the user level of what are their needs and what are their functions and what are their interfaces and their design. And then you take it down. I think Lou likes to use the word design input requirements as compared to user requirements. I do it one more time, but you keep on going lower in level. And I think, Lou, was that what you were going to say?
Oh, yeah, yes. And I wanted to say that, you know, it was really good to see the presentation, and then, you know, Henrik's description, because basically the process that you described is pretty much the process that's in the manual all the way through. It's, you know, spot on. But, you know, you made a very good point, is that there's this overall framework of all these things to do, but you got to decide for your project and what you're trying to accomplish, what makes sense, what's going to add value, and what's just a whole bunch of stuff that doesn't add value. And that zero-based approach, I know I first learned about that when they had to redo the requirements for Orion when they were bloated. 10 years ago, they got way out of hand and they had to go to that zero-based approach where you fight to add requirements. You don't just accept everything, And so the same is true with the processes, what makes sense, what gives us value. And I think that's what everyone should view the manual for is that's what it's intended is I don't anticipate everyone doing everything in there, but do what makes sense for your project. But everything you have in there, that traceability fit in real well with Henrik is talking about, that live traceability across the life cycle. I think we're all on kind of the same message.
Yeah, I don't think there's anything here that contradicts. We might have taken more shortcuts than someone else would have, but that was sort of what we were being paid for.
Yeah. But that was justified for your context.
Yes, sir.
For what you were doing, it made sense.
Thanks.
All right.
Anyone else have anything, or I'll give it back to Tammy.
Yeah, I was to say, I know you didn't quite want to go the full hour, so we've been at 45 minutes and I know it's getting late. If there's not a lot of pressing questions, I'm going to go ahead and stop the recording and do the wrap up, and we might be able to end this a little early tonight. Are there any last minute questions for Tony before I stop the recording?
One quick question. I think you mentioned that you may have used this approach for more than one project. After doing a few projects, do you have some kind of like template or system that you can use for different projects, and you kind of know how to set it up from the beginning, and you just tailor your SharePoint meta schema, so to speak? Anything like that?
We've dreamed of having a little package that you here, click on this link and it will set up your SharePoint to do what we did. We never had the resources to really put that together. It was never a case where we wanted to gift anyone with what we use, because we knew there were many things we wanted to improve and we wanted to talk about it. What I have done has been much more limited cases where if I'm doing really upfront requirements definition, I might pop up a SharePoint list and start using that to capture them because it's a convenient way. We're not believing that we're going to be using that end to end, but as a convenient repository. Or probably the thing I use the most, and I do build it from scratch each time, and it's not really that cumbersome, is the design review page, where when you give them a portal, basically, that on all in one place, you can define your entry and exit criteria. You can show what your evidence is that you're bringing to the game. You can provide them a place to comment, maybe even link their comments to the product they care about. That's pretty handy, but I do build it from scratch each time.
Thank you.
It's always different, right?
Yes, yes.
All right. Okay, over to you, Tammy.
All right, I'm going to stop the recording, and if you don't mind, I'm going to share my screen. So